Right. Bumping over is something like this. Bumping over with the next application. Bumping. Bumping over means now there is a bump. There is a bump on the road. So vehicle is going over there. Vehicle is going over there with velocity v. So let's say if we complete the invisible part of the bulb underground, let's say that one, the radius is r. So the normal reaction will be acting n upward. So let's say it is capital R normal reaction, radius will be simple r, mg will be acting downward. So now what will be the equation? F equal ma downward. The centripetal force is acting towards the center. Then mg minus r equal m v squared over r. Thus, what can we say? We can make, if you want, we can make v the subject, right? Or r the subject according to the question. I have made v the subject. So here r, here v. Then v squared equal r times mg minus r over m. That means v is the root of this. Right? Very simple. Nothing much in that application. Okay. Then okay. Let's first write this. Let's draw and write quickly. Now in vertical motion, there is one important factor you must deeply take it to your mind. The factor is this. Earlier we did the horizontal motion. Now in horizontal motion, the velocity, I mean the speed did not change with the position. The speed did not change with the position. The velocity of course changed because of the change of direction, but the speed did not change. At every point, the object had the same speed, but here in the vertical motion, the speed changes from point to point because of the gravity. So at one point with the velocity, it is acting, the gravity is, if the gravity is acting downward and the velocity is also downward, then the velocity will be greater. And in another point, if it is going up, right now, it is going in a circle, you know. So this part, when it comes down, gravity is also pulling it downward with an acceleration. The object is also coming down. Then what happens? The velocity increases. Then once again, when it goes up, the object is trying to go up. It has the velocity upward, but gravitational acceleration is downward. So the object has a deceleration, tries to decelerate. So the velocity doesn't increase. So that is one important factor. Then now, if by any chance we cut the string or the thread or wire of a system having a ball or an object attached at the end of the wire and whirling in a vertical circle, what happens is the object will try to go in a projectile path. The object will try to go in a projectile path. Then we can denote it like this, right? Now let's say, yes, then let's consider this one. Right here you have, here is the circle. Then at the highest point, now consider the case where the object is going passing through the highest point. Then uh, so mg is acting downward, t is also acting downward. So you can write downward equal ma equal mg plus t, right? Mg plus t equal m v squared dou r. If the radius is r and going with v, let's say like that. But if the object just passes the highest point, what will happen? now the object just passes the highest point. Object just passes the highest point means it is just touching the highest point. That means at that moment we consider the tension to be zero. If the object just passes the highest point, we consider t to be almost zero. Now let's see what happens. Then when tension is almost zero, the velocity that it has such that it can pass the highest point, it can just pass the highest point, is called the minimum velocity. Is that clear? When the tension is zero, the velocity that the object has such that it can just pass the highest point is the minimum velocity, because if it has a velocity lower than that minimum velocity, it will not pass the highest point. It will just fall. Right. Now let's see. So V mean 0 plus mg equal in V mean square dou r. Right? V mean square. If I write it little bigger, 0 plus mg equal m. So yes, m V mean square dou r. Right. So now mm will cancel. V mean will be equal to the root rg. Will be equal to root rg. So to move in a circular path, the object that the velocity that the object has should be greater than or equal to v mean. Otherwise, it will fall you to move in a circular path. What is the condition? V mean should be greater than or equal to, sorry, V should be greater than or equal to V mean. Then V should be greater than or equal to root rg, in other words. So if it is less than, what will happen? If it is less than that, it will it will definitely fall. And let's say let's forget this equal sign. Let's forget this equal sign. Now to travel in a circular motion, vertical circular motion, yes, the velocity should be greater than the v mean. Now let's say what will happen if v is v mean. If v is v mean, what will happen? If v equal v mean, then what is the case? Now f equal ma, we'll apply f equal ma. downward. Similarly, F equal ma, so you have T plus mg equal m v min squared over r. Okay, then v min squared. V min squared is rg, right? So m into rg over r equal T plus mg. Then what happens? R cancels here, so here becomes mg. Once again, here becomes mg. So mg cancels, so you have T0. So the reverse of the result we got on this side. Reverse of the result. Then if velocity is v min, it will not pass through, it will not pass the, it will just pass the highest point, but it will not complete the circular motion. It will travel in a projectile motion. So at that case, in this case, this is the motion of the object, right? Here it is the object. This is the object. So it will go through a projectile motion. It will go like, so this is a projectile motion. As if it is projected, right? It's going like this. Going and falling down, right? Not completing the circle at the moment, at the instance. What is the condition? T equals 0 instance. Okay. So we will write a small note before we draw it. Now write like this. Write this. The most important velocity in vertical motion is the velocity at the highest point. The most important velocity in vertical motion is the velocity at the highest point. When an object is moving in a vertical circle, from point to point, the speed will change. When an object is moving in a vertical circle, from point to point, the velocity or the speed will change. Speed change කිව්වම ඉතින් velocity එක change වෙනවා කියන්න දෙයක් නැහැ. කොහොමද change වෙනවනේ. This is because the gravity is acting on the object. This is because the gravity is acting on the object. If the object just passes the highest point, if the object just passes the highest point, the tension in the string is 0. The tension in the string is 0 and the object will fall in a projectile path.
The tension in the string is 0 and
the object will fall in a projectile path. at this moment, the velocity at the highest location, is called the critical velocity. Right, let's draw. Now I give you a question like this. Just an example question. If the velocity of an object at the lowest position of a vertical motion of a vertical circle with radius r is root 5 rg, will it execute vertical circular motion? Right. Try to do it. What? 2 minutes. Just this. Just draw a diagram. Just draw a diagram. Then you will have, at the minimum point, you will have velocity root 5 rg. Then at the highest point, take the velocity as v. Then here, take this as the reference level. So total energy at, let's say this place is A, this place is B. Total energy at A equal total energy at B. So total energy at A is the kinetic energy. Kinetic energy at A is equal to kinetic energy at B plus also gravitational potential energy at B. So kinetic energy at A is half m 5 rg. 5 rg square, then 5 rg. Then kinetic energy at B is half m v squared plus this one is mgh. So mgh is 2r. Now you can cancel half and multiply all by 2. Then here will be 5 rg equal v squared plus 4 rg. So take 4 rg here, then it will be rg. So v will be root rg. But you know the velocity at the highest point should be greater than root rg to just pass the, to execute the circular motion. But we know VB should be greater than V min equal root R G to execute vertical rotational motion, vertical circular motion. So this will not execute vertical circular motion. Okay, got it. Did you understand that?
Yes.
Okay, then let's write it. Then new topic, we are moving to rotational motion. So new topic is rotational motion. Rotational motion. So under rotational motion, the first one is moment of inertia. Moment of inertia. What is this moment of inertia? Moment of inertia means actually it is going with the first second law of Newton. Newton's second law. What he said in the second law, if an object, unless an external force is acting on the object will remain at rest or travel with constant velocity or rotate with constant angular acceleration, angular velocity. Yeah, third part එක අපිට පොඩි කාලේ කියලා දෙන්නේ නැහැ. අපිට ඒක තේරෙන්නේ නැහැ. ඒ ඉඳන් මුල් කැලේ දෙක විතරයි කියන්නේ. third එකේ තව කැලලක් තියෙනවා. මොකද්ද? Second එකේ unless an external force is acting on the object, the object will remain at rest or travel with constant velocity. ඔච්චරයි නේ කියලා දෙන්නේ පොඩි කාලේ O level පන්ති. ඔය තව එකක් තියෙනවා මොකද්ද? rotate with constant angular velocity. Angular velocity කියන එක පොඩි කාලේ දන්නේ නැති ඉඳ ඒක කියන්නේ නැහැ. But it is there in the second law. So it is connected with this moment of inertia. This moment of inertia says moment of inertia කියලා කියන්නේ the reluctance of an object to change its state of rotation. කියන්නේ කොහොම හරි rotate වෙවි තියෙන object එක එයාගේ state එක වෙනස් කරන්න. ඒ කියන්නේ either to give a deceleration or acceleration or to change the direction of rotation. The reluctance means the unwillingness, අකමැතිකම. Moment of inertia කියන්නේ object එකක් rotate වෙවි තියෙනකොට එයාගේ state එක එයා වෙනස් කරන්න තියෙන අකමැතිකම. Right? I will write it for you. The reluctance of an object to change its state of rotation is called moment of inertia. Is called moment of inertia. So this moment of inertia depends on two things. What are the two things? Mass distribution and the axis of rotation. Mass distribution and the axis of rotation. So depend on mass, depend on axis of rotation. Axis of rotation. So now if we consider a system of masses, let's say I will draw it a little bigger. So let's say here it's the center. So here M1, M2, M3, M4, Mn, right? Then here, let's say perpendicular distance to M1 is R1. Now it is going with velocity V1. Perpendicular distance to M2 is R2 going with velocity V2. Like that, same for others. V3 R3. V4 R4. Then finally, there are n number of mass particles. Then Rn Vn. Right. Now this is how the inertia is taken. Inertia is called I. I means mass multiplied by the distance to the axis of rotation, right? Is mass multiplied by distance, perpendicular distance to the axis of rotation. Axis of rotation is the center, you know. So the system, whole system is rotating like this. Mass into perpendicular distance to the axis of rotation squared. The axis of rotation squared, right? So now for this one, let's say M1 R1 R1 squared plus M2 R2 squared plus M3 R3 squared plus M4 R4 squared plus blah 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 plus Mn Rn squared. That is the moment of inertia of the system. Then what are the units? What are the dimensions? Dimensions are ml squared. Ml squared. So units are what? M is kg, L is meters, so kg m square. Okay, did you understand that small part? Hello.
Yes, sir.
Okay. Then let's write this. Okay, let's write this. Now this you can easily understand that the moment of inertia will change according to the mass and the axis of rotation. So if the mass distribution changes, no, if the axis of rotation changes, the mass distribution will change, and then the moment of inertia will change. Okay, if the axis of rotation changes, the mass distribution will change, then the axis of rotation will change. The moment of inertia will change. Now here, the axis of rotation is like this, right? Like this. So it is rotating like this, you know. That's why the object is going, the whole system is rotating like that. But if I rotate the object somewhere here, the axis of rotation will be like this. Then if I rotate it, then a larger part will be there to my right hand, to my left hand side of the axis of rotation, right? So if I connect it here, this larger part will be there to my left hand side of the axis of rotation. Then to the right hand side of the axis of rotation, a smaller part will be there. So once again, the system will go like this, right? Go like this, but the mass distribution is different.